atomic radii, ionic radii, then melting point, boiling points, enthalpy of atomization, then ionization enthalpies, electrode potential. Then we have discussed about the oxidation states, and I have also told you why different oxidation states are stable and unstable oxidation states. Either they try to attain more stable oxidation state either by the loss of the gain of electrons, and on the basis of that, those substances either act as oxidizing and reducing agent. Then after that, I have discussed about formation of colored compounds, magnetic properties. We have done the calculation also magnetic property. Then we have discussed about the interstitial compounds, then alloy formation. Okay. And now I'm going to discuss tendency to form complexes. Most of the transition elements, they form different types of complexes or coordination compounds. Tendency to form complexes. Okay. Transition metals show a strong tendency to form complexes or coordination compounds. Okay. Then why? It is because of its one small sizes of transition metal ions. Second, high charge by radius ratio, and third, ability of empty d orbitals where ligands can donate pair of electrons to form coordinate bonds. This is important for exam. But let us try to understand. See, what is this? Though we have not discussed about the coordination compounds, it will be little difficult for you to understand. Suppose I have taken here Mn plus, and this is the ligand. Ligand always supplies lone pair. See, it has to supply electron. If it has to supply electron, the metal should be highly electron depleted. That is, the nucleus should have a strong tendency to take that electron, and that is only possible if the empty shell of the outer orbital is very close to the nucleus. Then only nucleus is going to form. So, first advantage is small size of transition metal ions. We know the size is small because of the improper splitting of the d electrons. So, because of that, the charge by radius ratio is more. What is the charge? Nuclear charge. Radius is less. So, radius is the denominator. And coordination bonds means what? Any bond formation takes place by the overlap of the orbital. So, ligand supply the orbital filled with electrons, and metals supply the empty orbitals. So, transition metals have many metal ions have lot of empty d orbitals where they can overlap and form the bond. So, we go to the now. Just like the p block elements we have discussed about the reactivity towards hydrogen, oxygen, halogen. So I'm going to discuss now the formation and nature of oxides. See, transition metals form varieties of oxides with different oxidation states. Transition metals form varieties of oxides. Oxides of different oxidation. Why they form? Because they have a variable valency. So now we find nature of some oxides. The low oxidation state oxides means what? Low oxidation state. Say it is +2, +3. Oxides are generally basic. Please remember, higher oxidation, any compound with higher oxidation states are covalent. So it should be ionic only. Okay. So let me give you the example. Scandium forms only one oxide. We know it has only +2 oxidation state. Scandium. Then titanium. Okay, I'll write down the oxidation. +2. Ti2. O3, this, then VO plus 2, V2, O3 plus 3, MNO plus 2, ferrous oxide plus 2, Fe2O3 plus 3. Okay. Cobalt oxide plus 2. Nickel oxide plus 2. Cuprous oxide is exception, you plus 1. This is plus 1. The higher.
So what's the second last one?
This one. This one.
No, sir. Below that.
This one.
Second last one, sir.
Second last. Oh, this is NiO. Nickel oxide.
Thank you, sir.
The higher oxidation state plus 5, plus 6, and you say oxides are acidic. So we are always being told metal oxides are basic. It's wrong. See, V2O5 plus 5, CrO3 plus 6, Mn2O7 plus 7. So they are acidic. I'll give you one example. Okay, two examples. CrO3. If you add here water, it will give you H2CrO4. It's called chromic acid. Okay. These acids are not that much stable, but they are more stable in their salt form. M12O7. It is plus 6, plus 7. 2, 8, MnO4. This is called permanganate acid. Okay. So now we'll have an intermediate range also. Intermediate range is 3 or 4. The oxides with intermediate range of oxidation states. Okay, 3 or 4. The line between that, then what should we call it? R amphoteric. It is they both as acid as well as a base. Example. Titanium dioxide, vanadium dioxide, See, this is +4, +4, +4, +3, +3. Then +4. This is exception. Copper oxide +2 and zinc oxide +2. These are important. To discuss about transition metal halides. Transition metals react with halogen at higher temperature. Okay. The order of reactivity is fluorine being the strongest electronegative element, very strong oxidizing agent, it reacts fast. Fluorine, iodine. Okay. Halides of transition metals in higher oxidation states higher oxidation states exhibit a greater tendency to hydrolyze. This is going to react with water. Okay. So say suppose titanium tetrachloride plus 2H2O TiO2 plus 4AC. This is one. Second, the highest oxidation state oxides of transition metals can be achieved only by most electronegative fluorine atom. The ionic character of transition metal halides decreases from fluorine to fluoride. Okay, fluorine RINE to iodine due to decrease in electronegativity. Okay, let me write here. Ionic character, and here I will write covalent C. It is I've taken with this cupric chloride, cupric bromide, and cupric iodide. Please see. Ionic character increases in this. This is the most ionic, and this is the most covalent. Hmm? Okay, now we come to a very important compound called potassium K2Cr2O7. First we'll go for preparation. For emboss, take care. If it did not come in this year, next year is going to come. Okay. It is prepared commercially from bromide ore. Okay, what's the formula? It is a joint oxide, FeO mixed oxide, Cr2O3. But generally, ore, what do you do? we write it empirical component, or we write here FeCr, FeCr2O. It involves following steps.
বাবা
হুম।
আমি বলি দুটো চক্কর আছে
যা
তাহলে কি প্রশ্ন একটু টাকাটা নিয়ে যায়
Acha, see, I have written down in detail, but in brief. So in that case, here I'm not going to write so much, okay? We'll write here now. 1. So, conversion of chromite ore to potassium chromate. Sorry, potassium A2Cr2O4. Oh, sorry. Sorry, I'm very sorry. মাথা একটু খারাপ হয়ে গেছে সোডিয়াম ক্লোরাইড Na2 CrO. So what do we do? We take chromite ore and we write here now. Powdered chromite ore is mixed with either sodium hydroxide or sodium carbonate and heated in presence of air. Sodium So it is 4. In your book they have given sodium carbonate, so I'm going to write with sodium carbonate. Okay. So FeCr2O4. See, in your note I have done the partial equation, so I'm not going to write it here. I'll write it. See this. This is insoluble. Okay. So now we have taken everything in dry in solid state. So you get it in solid form. Okay. Then what you write now here? Second. Conversion of sodium chromate to Sodium dichromate. See, this is a solid mass. So what do you do? The solid mass is extracted with water and filtered. So filtrate contain this one. And this is the residue. The filtrate is treated with dilute H2SO4, which converts it to sodium dichromate. So I'll write now here Na2CO4, then H2SO4, you will get here Na2Cr2O7, sodium sulfate plus H2O. We have to convert this into potassium dichromate. গুড্ডু হলে একটু বাকিগুলো হাঁটিয়ে যা হাঁটিয়ে না না আমার কইয়ে গেছে না হয়ে then conversion of sodium dichromate to potassium dichromate. The solution is wait, let me see. Sorry. The hot solution is treated with calculated amount of potassium chloride. To form K2Cr2. The solution is cooled to precipitate precipitate sodium chloride and filter. The filtrate is concentrated to obtain orange crystals of P2 Cr2O7. Okay, so now I'm going to discuss a very important portion. Is the effect of pH. The effect of pH. Effect of pH. Please remember. In acidic condition, it exists as K2Cr2O7 or Cr2O7 2 minus. And in basic condition, I'll change it later. Basic condition means what, dear? At lower pH means below 7. And in basic medium or at higher pH. It exists as K2Cr4 or Cr4 2 minus. Please remember one thing. Here the oxidation is not an oxidation reduction reaction. Oxidation state of chromium in both the cases +6. Okay, so I'm going to write. So what is going to happen? When this question will come. Acidic medium or lower pH. See, if you have taken here potassium chromate, I am writing in very detail. Okay, and here color is yellow. To that, if we add here H2SO4, it will give you, K2 Cr2O7 K2SO4 and H2. But I'll always say not to do like this. So this is potassium dichromate, orange. Always do in this one. CrO4 2 minus. I'm not writing oxidation state because it is not a question of oxidation reaction. So you know that it will be get converted into Cr2O7 2 minus. Okay. So how to balance it? See how many chromium? 2. So right here 2. 2 chromium, 2 chromium. 8 oxygen, here you have 7. Then what is going to happen now? You write here now. 2H plus H2. So easily you can do it. Ion electron method is very easy. Basic media. It is reversible basic media. So right now here K2 Cr2O7 potassium. Oh, please write here chromate. Chromate ion. Here you write dichromate ion. Okay, I'll write. Ajay, what about Zedin? I have not seen her name for a long time. Zedin, are you there? Hello?
So we have exams right now.
Oh, acha. So potassium dichromate. Okay, now in basic medium. So what you are going to get here? You will get here CrO4. So you will get here now potassium chromate. Come wrong? Orange. What do you say, Khasi? Orange color?
Wrong, sir.
Wrong, sir. Very good. See now. So how many potassium? 2. How many potassium? 2. How many chromium? 2. Only 1. So let me write it here. Okay? Oh, sorry. I've written 2 here. Sorry, dear. 2. So chromium. Now I require 2 more potassium. I'll write now here 2 KOH. And here I'll write H2. Let that. Okay. Now I'll do ion electron method. See here. Here it is Cr2O7 2 minus. Here it is CrO4 2 minus. So here I'll write 2. See, it is 7 and it is 8. I require 1 more oxygen. What should I write down here? See, for 1 oxygen, I'll take out from here. And here I'll write this. So, dichromate ion. Chromate ion. This is important for exam. And try to do by this method is easy. Otherwise, you'll make mistake in balancing. Chemical properties of dichromate. The nights are getting colder here. Sometimes I feel so lazy to take your class. But anyway, as I have promised you, I have to take. Okay. So chemical properties. Action with acids. This is not there in a book. Huh? Please excuse me for this. Reaction with acids. Please remember, when heated with acids, liberate oxygen because it is an oxidizing agent. Okay. So A2C. It is here. The question is not potassium. Question is chromium +6. So potassium dichromate and sodium dichromate show same reaction. In fact, in the laboratory, dear, we do not go for potassium dichromate. Why? Because potassium dichromate is very costly. We take sodium dichromate. But if I have to go for titration, I have to make a standard solution. So in that case, we do not take sodium dichromate, we take potassium dichromate. Why? Because sodium dichromate is hygroscopic. By the time you take weight of the substance, it is going to absorb so much of water, your weight will be wrong. So please remember, in titration or in volumetric analysis, potassium dichromate is taken. Otherwise, for oxidation purpose, we take sodium dichromate because it is cheaper. Okay. Now, no, I will not do like this. Let me give you a little more information. And I always think that I should not trouble you, but sometimes I feel that suppose if it comes in the entrance exam, then the tum log ko bahut gali dega. Unnati men to hopeless. You will say like that, na? Huh? With cold and concentrated H2SO4. Potassium dichromate.
Sir, is that which cell?
With cold and concentrated H2SO4. Comma. Potassium dichromate gives CrO3 chromium trioxide. So let me write K2Cr2O7 and H2SO4. Okay. So it will give you 2KHSO4. Then it will give you CrO3 plus H2. So it's only for your entrance exam. Okay. Now, with hot and नहीं तो hot नहीं to dilute देने से होगा with hot sulfuric acid it liberates oxygen. Okay, so I'll write now here K2 Cr2 or 7 H2SO4. Okay, I'll write here 3. So it will give you potassium sulfate and not 3, 4. Cr2 SO4 3. Chromium valency is 3. Okay. Plus 4 H2O. 3 oxygen, I think. Yes. Okay, so if you with HCl, HCl में क्या होगा?
The current environment, no, I feel like the Bombay.
काय ते पण नका
Seven H2O ना plus 3O. अच्छा देखता है तो करेक्ट है कि नहीं? अरे गड़बड़. So how many Cl? Cl is here 14. इधर में कितना है? 6 plus 2 8. So 14 minus 8 is how much? Yes, reverse chlorine. So it is wait. 2 plus 6, 8 plus 6, 14. Yes, correct. So it liberates chlorine. Adapt.
Right, sir.
Yes, sir.
Okay. Now it is known for its oxidation. Huh? See, I told you only yesterday. Yesterday over. Yes. That chromium oxidation state of chromium in dichromate is +6. So it is having D0 configuration. But chromium is more stable in +3 condition because of its small size, which can be properly hydrated by water. Okay, so now we write here now. Oxidizing nature. So what we write now here? Potassium dichromate or sodium dichromate are strong oxidizing agents. in acidic medium. Why not basic medium? Because in basic medium it will no longer remain as dichromate, it will convert to chromate. This simple thing you remember. So how does the oxidation take place? Let us see. K2 Cr2O7. Just now I have done for you 4 H2O gives you what? Potassium sulfate, chromium sulfate plus 4 H2O and see, this is the nascent oxygen which carries out oxidation. Please remember. Now I'll do is ion electron method that you have done long time back in your childhood when you were in class 11. More. So what it will give? Cr3 plus C. I told you this is more stable than this. So from +6 to go +3, 2 chromium, I let me write here 2. So each chromium is coming down from +6 to +3. Take 3 electron, 2 chromium, 6 electron. So it is 6 electron. We have 14H plus. So we have 7 molecules of water. So always try to go by this method. Don't go for this method. Unnecessarily you make your life hell. Okay, now we are going to discuss examples. Okay. So we'll write now here. It oxidizes ferrous sulfate. I have to write in words because you are horrible species. Oxidizes ferrous sulfate. Because you do not know the name and the formula. After a few days, if someone shows you your photograph, you will not be able to identify. Ferrous sulfate to ferric sulfate. Fe2 SO4. Okay. That is what? Fe2 plus 2 Fe3 plus. I'll do by this method. See. In ion electron method, what you are supposed to write? You are supposed to write first the oxidation followed by reduction. So right now here Fe2 plus Fe3 plus 1 electron. I'm not going to balance it. You will do it. See here Cr2 O7 2 plus. Une plus 6 Cr3 plus. Une plus 3. So write this equation and balance. Do. You are not babies.
They are also not done this in the past. Somebody else has done it for them. So we don't know how to proceed. हम लोगों ने सोचा था कि एक्सेल को ही हम लोग फिल्टर करके दे चैलेंजिंग और भी तो पार्ट कर सकते हैं बट अभी ये आईडी से हम लोग फिगर आउट नहीं कर सकते कि कौन सा iOS है और कौन सा Android. We don't have the understanding and things to follow.
Hello, Miss Rao. Hello. Not there. Bipasha is there. Bipasha also missing. Eugenia missing. Lavan done? Lavan? Hello, Lavan. जल्दी करो 6 electron 14 each plus, then here 7 waters. See here 6 electron has to be provided by the first equation. It is multiplied by 6. Add. Hi Drishti to asre nai. Drishti?
মামা আসো
তাতে তো মিস রাও বলি কত কি মাপ দিয়া নাই
ও না মোৰ ভলিউমটো অলপ কম আছিল
ৰ মই আহি পাম দে তোৰ ঘৰত ভলিউমটো মই এনে বঢ়াই থম দাঁড়া মাথায় পাঠাইম তোৰ So now, second, it oxidizes iodide, means what? I minus to iodine, I2. So right now here, I minus, here I'll write I2. So I know I require two iodide to get I2. So right now here 2, each of them is going to lose 2 electrons. So this, after that, write this one and balance. Mansan?
Yes, sir.
Good. Okay, now we'll do 2, 3 more. Third. It oxidizes SO3 2 minus 2. Sorry. Sulfide means it can be sodium sulfide or potassium sulfide to sulfate. SO4. Oh my, okay, I'm going to do this one for you because now your temperature is going down. Maybe that your activity of your brain has decreased. Okay, so right now here. This is +4. This is +6. Here 3 oxygen and 2 oxygen. We know it. Then in acidic medium, oxygen comes from water. So I'll write here now 2H plus 4 to 6, 2 electron. Rest you do. This also I'll do. I told you the thing which does not appear, first you write it. Okay. Then this. See here. It is 6. 6 and this is 40. So this side is more. So we'll write now here 8H plus. Water, here it is 3, here it is 7. So it is 4H2. Four. 8 oxidizes H2S to sulfur. Okay, now if I have to write ion electron method, S2 minus to S.
Lifeline.
Okay, so I'll write now here. S2 minus S plus 2 electron. Okay, rest is same. So it is 3S2 minus 3S. Okay. You can carry out so many oxidation reactions. Now forget. I told you the technique to do it, you know it. Now we'll go for chromyl chloride. Chromyl chloride test. This is a test of chloride ion. When a mixture of metal chloride then potassium dichromate and concentrated H2SO4 is heated. And orange, red, vapors of chromide, chloride. Their formula is CrO2, Cl2. Are evolved. This is also important for your. Okay, so let me write its reaction. Okay, so I write now here. K2 Cr2 O7 H2SO4. So we get here now 2AA KH, it's the potassium bisulfate, plus 2 CrO3 plus H2O. Okay, I'll do it by only by ion electron method, and it is comprising of 3 steps. So you do not get nervous. KCl plus H2SO4 that we have already learned from our Q block. What it will give you? It will give you HCl. Now this HCl is going to react with chromium trioxide. Chromium trioxide is a strong oxidizing agent. Okay. So it will give you CrO2, Cl2, and H2O. Things seem to be very simple, but actually it is not. How many chromium are there? 2. This is equation for 1. Try to always think simpler. Life will become so happy. See here. So 2 multiplied by 2. Then how many HCl are required? 4. This gives you how many HCl? 1. Then multiplied by 4. Then the last depth. See here. Une gone. Une finish. Add. So you don't have to worry so much for equation. It will get automatically balanced. See, chromyl chloride you have already used in your conversion of toluene to benzaldehyde. Remember? Chromyl chloride test. We have done in Etard reaction. Remember? Don't remember, na? See now. Okay, now I'm going to draw the structure of C. This C. This is the main structure. Potassium, it is there, or sodium. Just wherever oxygen is there, side by side, you put potassium. So it is Cr. They are all tetrahedral here. This is this. This is the one. If they give potassium, don't write negative sign, put potassium here, potassium here. Sodium, put sodium, sodium. Cr2O7 2 minus. Okay. Please remember these two structures are important for your exam. Put minus here, lot depth. CrO2, Cl2, it is not being given in your book. But if you are intelligent enough, what you will do? Wherever single bond is there, put chlorine. तो हो गया. শেষে গেছে এটা শেষ অনেক গুড নাইট করি
তুমি খাবে
আমি আপ দিয়ে খেতাম let up.
Yes, sir.
Yes, then good night. See you tomorrow morning.